This is Mr. McGough up in R12, and I will be going over Unit 2, Day 12, Solving Absolute Value Inequalities. Now to start off, we want to make sure we understand what an absolute value really is. It is a distance away. You can either be to the left or to the right, and either one is the same distance away. So for example, an absolute value of positive 1 is 1. It's 1 away from 0. The absolute value of negative 1 is also 1. It's 1 away from 0. So when we solve an absolute value inequality problem, we want to break it up into two problems. So for example, on number 1, the value of x will either be less than or equal to 9 if x is positive, or the value of x will be greater than or equal to negative 9. So in either case, we want the distance from 0 to be less than 9. That's the entire solution for number 1. Either x is less than or equal to 9, or x is greater than or equal to negative 9. On a number line, we would mark negative 9 and positive 9. And we know that x can be negative 9 because equal is included. And it can be positive 9, and it can be any number in between. So let's think about the number 2. The absolute value of 2 is 2, and 2 is less than 9. Let's think about the value negative 2. The absolute value of negative 2 is positive 2, and if we look back at the original problem, positive 2 is less than or equal to 9. Or we could think about the second half of writing out our formula, where negative 2 is greater than or equal to negative 9. It falls between those two values. So go ahead and write down your answers to letter A. Pause the video and solve. Okay, so if you pause to solve, we see that there are two potential ways to solve x. Either positive x is greater than 12, or x is less than negative 12. Both of those values are 12 away from 0. And we have to keep our symbol, and we flip it for our negative solution. So we can use this again for our follow-on problems. But now we have where either the value inside of our absolute value, 2x minus 7, is greater than or equal to positive outcome, or the value inside of the absolute value is less than or equal to the negative of that problem. So let's solve these one at a time. So 2x minus 7 greater than or equal to 15. I'll add 7 to each side. 2x is greater than or equal to 22. I divide both sides by 2. And x is greater than or equal to 11. In our second expression, or second inequality, here we'll add 7 to each side. We'll have 2x is less than or equal to negative 8. I'll divide both sides by 2. And x is less than or equal to negative 4. So on a number line, we would have x greater than or equal to negative 11, or x less than or equal to negative 4. Let's pick a number and try it. If I put in 0 for x, which is not part of my solution, I would have 2 times 0, which is 0, minus 7, which is negative 7. I would take the absolute value of that. The absolute value of negative 7 is positive 7. Is 7 greater than or equal to 15? No, it's not. It is not part of our solution. But let's say we took the number, a large number, bigger than 11. Say we took 20. The absolute value of 2 times 20 minus 7 would be 40 minus 7, which is 33, and 33 is greater than or equal to 15. That's the positive side. And on the negative side, let's say we take negative 5. The absolute value, 2 times negative 5 is negative 10, and then I would subtract 7. So this would give me negative 17, and the absolute value of negative 17 is positive 17, and positive 17 is greater than 15. So that is also a solution. That's how you can check your work. I'm going to clean a little bit off of my screen to make room for the next problem. Oops. If it won't run away on me. So now we have 9 minus x strictly less than 2. So again, we have two potential solutions here where 9 minus x, the positive, is less than 2, or 9 minus x, the negative, would be greater than negative 2. So we'll solve the left equation first. We'll subtract 9 from each side. We'll bubble and split, keep everything nice and neat. So we would have negative x is less than negative 7. Well, I don't want to know about negative x. I want to find positive x. So I need to divide both sides by negative 1. When I do that, I have to flip my inequality sign. So x would be greater than negative 7 divided by negative 1 will be positive 7. On my second solution set, I'll split and bubble. Now I need to subtract 9 from each side. So negative x is greater than negative 11. I'll divide each side by negative 1. So positive x is then less than positive 11. So on a number line, this would be the values of x between 7 and 11. So let's try the number 10. 9 minus 10, absolute value, equals the absolute value of negative 1, which equals 1. And 1 is less than 2. So our solution set works. On number 4. So here we have an absolute value expression and something outside of the absolute value. So like I've shown you, first we're going to circle our expression with the variable in it, that absolute value, and we're going to work outside of the bubble first. So I'm going to add 3 to each side. So we have absolute value of x plus 8, strictly less than 8. Now I have to split up my problem into two parts, or the positive answer, or excuse me, the positive absolute value x plus 8 is less than 8, or x plus 8 is greater than negative 8. Again, I solve the left problem first, subtract 8 from each side, and x would be less than 0, or I'll subtract 8 from each side. X is greater than negative 16. So we need a number between 0 and 16 to check, 0 and negative 16 to check, so I'll try negative 1. So negative 1 plus 8 minus 3 should be less than 5. So the absolute value of negative 1 plus 8 is the absolute value of 7. The absolute value of 7 is 7, so 7 minus 3 less than 5. Is that true? Yes. 4 is less than 5. So here's our solution. I'll go ahead and let you pause your video and work through B. So if you paused your video and worked through that, you'd see that the thing that we have outside of our absolute value is a multiplier, a coefficient, negative 3. Well, negative 3 is being multiplied by the absolute value, so to get rid of it, we have to divide. I'm dividing by a negative number. When I do that, my inequality flips. So on the right, negative 12 divided by negative 3. A negative divided by a negative is a positive. 12 divided by 3 is 4. I flipped my sign, and now I have absolute value x plus 2 less than or equal to 4. Now I'll split this out into two problems. So either the positive outcome of the absolute value is less than or equal to positive 4, or the negative outcome of the absolute value is greater than or equal to negative 4. I'll solve the left equation first. I'll subtract 2 from each side. And I get x less than or equal to 2. On the right equation, I'll add 2 to each side. Correction. Made an error. It should still be plus 2. So I'll subtract 2 from each side. And x, therefore, is greater than or equal to negative 6. So our solution would be the values greater than or equal to negative 6, but less than or equal to positive 2. We want a good round number. How about 0? We'll plug 0 in for x. We'll have negative 3 times the absolute value of 0 plus 2. We're going to check to see if that is greater than or equal to negative 12. Negative 3 times the absolute value of 0 plus 2. 0 plus 2 is 2. The absolute value of positive 2 is 2. And now we'll multiply negative 3 times 2. We get negative 6, and that is greater than or equal to negative 12. On number 5. Again, we have an absolute value with a multiplier out front. We will divide both sides by negative 4. We get the absolute value of x plus 2 is greater, flip it, is less than negative 4. So we have an absolute value on the left. An absolute value is always a positive number. On the right, I'm saying that that positive number is less than negative 4. What value of x could possibly make a positive number less than a negative number? The answer is none of them. So this one, no solution. We don't even need to split it up. If you did split it up, you'd see that there was still no way to have a solution. On number 6. Here I'm going to add 4 to each side. So I'm going to work outside of the absolute value first. I'll add 4 to both sides. And the absolute value of 9 minus x is greater than or equal to negative 12. Like in number 5, the absolute value, regardless of what x is going to be a positive number. And that positive number has to be greater than or equal to negative 12. What positive numbers are greater than or equal to a negative number? All of them. So all real numbers, or A-R-N. And that's the end of day 12.